Welcome to my YouTube channel. I'm Arthur Francis Divan. I advise you to always subscribe and press the like button. So today we are going to be dealing with determination of molar mass or relative molecular mass questions. Like I told you earlier on, I've given you all the formulas you need, which will be able to aid you in understanding how the process goes. Without those formulas, it's going to be difficult for you. You have to be consulting your books in order to get along. So please go back to our second video, if not mistaken, that you'll be able to get the formulas therein and match up or meet up with the necessary demands, which is right now. So we're going to take our first question. Remember, like we do it, I read a question for us, and during the given, you'll be able to see the variables that are required of us. Then we can proceed from there to solve whatever is required. So A is a solution containing 3.7 GDM cube of an acid, H2X, that is the acid. B contains 2.15 gram of sodium hydroxide per 250 cm cube of solution. Put A into the burette and titrate it against 25 cm cube portion of B using methyl range as indicator. Calculate the average volume of A used. Now, since it's a titration question, it is believed we've done the titration and the average volume of acid is 26.60 cm cube. So they also give us, the equation of reaction is given. Relative molecular mass, they will always give you the equation of reaction. Now, from the result and information provided, we should calculate the concentration of B in mole per dm cube, concentration of A in mole per dm cube, and molar mass of H2X in G mole. So let me start with the given, so from there we can move on swiftly. A for acid, and here is our B for base. Now, A is a solution containing the acid is H2X, and it is 3.70 GDM cube, the acid, 3.70 GDM cube. B is 2.15 gram in 250 cm cube of sodium hydroxide. So here we have sodium hydroxide. Now, let's say we put A and all that, the volume of the acid, VA, which is at the end of the titration, is given to be 26.60 cm cube. The volume of the base, VB, is 25 cm cube. Okay. Now they gave us the equation of reaction. So we have our, here CA, we don't know. CB, we don't know. NA, we don't know yet. NB, we don't know until from the equation of reaction, which they've given to us, 2 moles of sodium hydroxide plus H2X will give us sodium X plus water. Now, we have 2 moles of sodium here, so I have 2 here. Water, 2 plus 2, 4. So I have 2 here for hydrogen. It's 4. Oxygen is 2. These 2 covers for that. I think our equation is balanced. So if our equation is balanced, then we can easily get our number of moles of acid. Okay, the number of moles of base here is 2. NB is 2. Number of moles of acid here is 1. Alright. 4. Good. So from here we proceed with our first question. What did they ask us to get? First question says concentration of B in mole per dm cube. Okay, count of B. A. Count of B in mole per dm cube. Now remember, there are various formulas we use to do that, the CAVA formula, but we can't use that one right now because we don't know the count of the acid and that of the base. And now they are asking us to get that of the base. And there's another way which we can do it. Concentration of the base or molar concentration is equal to mass concentration all of our relative molecular mass. We can get the relative molecular mass from the sodium hydroxide, which is 40, but the mass concentration is still not given. But we can use the formula mass over volume in DNQ, mass over volume, because they give us the mass and the volume to get our mass concentration of the base. Then we can now proceed to get the molar count of the base. So let's see that. So count of B in mole per DNQ, we first get our mass count. Okay? Now, mass count of B is equals to mass in gram over volume in DNQ. And the mass in gram is given to be 2.15 gram over the volume is 250 divided by 1000 in DMQ. And this is equals to 2.15 gram over, now 250 divided by 1000, we got 0.25. So this is 0.25 DMQ. Therefore, 2.15 divided by 0.25 will give us 8.6. So this is 8.6 GDMQ of B. So we've gotten the mass concentration of the base. Now we can now deal with the formula which I said, molar count. Remember they are asking us to get the molar count of the base. So the molar count of the base can now be mass count over relative molecular mass. I've gotten my mass count of the B. The relative molecular mass is 40. So this divided by 40 will give me the molar count of the B. So permit me, let me clean this so that I can proceed. Now, let me put it up here. 8.60 GDMQ, mass count of B. Count of B, molar count of B is mass count of B over relative molecular mass of B. And this is equals to, the mass count of B is 8.60 GDMQ over the relative molecular mass of sodium hydroxide is 40 gmol. And this is equals to 0.215 mole per DMQ of B. So here, CB is 0.215 mole per DMQ. So we've gotten the molar count of the base. Next question says the concentration of acid in mole per DMQ. They are now asking us to get the molar count of the acid. Remember, this formula we use, which is mass count over relative molecular mass, cannot apply here. Because here we have the acid is H2X. We don't know what X is. X is unknown. So we cannot calculate the relative molecular mass here. So the only way we can go about this is to use the CAVA. And that is why I think they asked us to get the molar count of the B first. Because by that, we can now get out of A. So let's see. Now B. Molar count of B. We use the formula, molar count of A. We use the formula CAVA over CBVB equals to NA over NB. We're looking for A, so CA is equals to CBVBNA over VANB. And this is equals to concentration of the base is given to be 0.125 times volume of the base is 25 times number of moles of the acid is 1 over volume of the acid is 26.6 times number of moles of the base is 2. This is equals to 125, that's the concentration, yeah, I think. 0.215, sorry. 215, not 125. 0.215 times 25 is equals to 5.375. 5.375 divided by 26.6 times 2. We have 53.2. So this is equals to 5.375 divided by 53.2 is equals to 0.1010, which is 0.101 mole per dm cube of E. So I can easily put that here, 0.101 mole per dm cube of A. So we've gotten our molar concentration of the acid. Now let's proceed. Lastly, molar mass of the acid, H2X. Now, relative molecular mass is equal to mass concentration over molar count. We've gotten our molar counts on both sides. So we can easily get the relative molecular mass like they are requiring from us, the molar mass of H2X. So C, and if you see molar mass of H2X. Remember, we don't know the acid, so X remain unknown. So for us to do that, we say molar mass is equivalent to mass comm of A over molar comm of A. And this is the mass comm of A is 3.7, I think that was given, GDM divided by the molar comm is 0.101 mole per dm cube. And this is equals to 36.6 G mole. The relative molecular mass is this. So we've gotten that the G mole for the acid is equals to 36.6 G mole of E. Now, if the relative molecular mass is this, although they did not ask us to know what is the value of X, but we can do that, or they can ask you any day, anytime, maybe in your exams or in your assessment or in your practice, you can say questions that will actually entertain that. So C, let's call it D for us to know what X is, to find X. So value of X, A, B, C, D now. The value of X, we say H2X is equal to the relative molecular mass. H2, which is hydrogen, is 1 times 2 plus X is equal to relative molecular mass, which is 36.6. Now 2 plus X is equal to 36.6. X is equal to 36.6 minus 2. X is 34.6. So that is the value of X. That's just a bonus. So you take that. Now let's move to the next question, please. Like I said again, I'll read it and put it given down. A is a solution of HCl containing 7.30 GDM cube B is a solution of X2CO3 containing 10.6 GDMQ. Put A into the burette and titrate it against 25 CNQ portion of B using methyl orange as indicator. The equation of the reaction is also given. From the result and information provided, you should calculate the conc of A in mole per DNQ, conc of B in mole per DNQ, molar mass of X2CO3, and like I said, we titrated it, so the volume of the acid is 25 CNQ. So let's put down the given. Our A now is HCl. Our B is X2CO3. Let's say A is 7.30 GDMQ, the mass concentration. Volume of the acid after titration is 25 CMQ. The volume of the pipette, VB, is also 25 CMQ. Now, the base contains 10.6 GDMQ. The mass count of the base, GDMQ, is 10.6 GDMQ. Okay. Equation of reaction, they give us, from here we have X2CO3 plus HCl. So this will give us, X chloride plus CO2 plus H2O. Okay. Now we have 2X. One hydrogen here. We have 2 hydrogen here. So if I put 2 here, I'll have 2 hydrogen balance. Chlorine, I have 2X. And I have 1 chlorine. So 2 chlorine now and 2X. I can easily put 2 here. 2XCl. What again? Hydrogen is 2. Hydrogen is 2. Oxygen is 3. Okay, that is 3. Now, let's proceed. Let's say, from our calculations and information, we should calculate the concentration of A in mole per DNQ. Conc of A in mole per DNQ. Remember the state. I may not be putting them here, but you should know that this is aqueous. Aqueous, gas, and liquid. So our number of moles of acid, Na, is 2. Number of moles of base is 1 from here. So from here they say we should get the concentration of the acid, that's the molar conc. Let me confirm that. Conc of A in mole per DNQ. Okay. Alright, let me take this out or let me leave it. A. Conc of A in mole per DNQ. From what we have here, concentration of the acid in mole per DNQ is always going to give us the mass concentration over the relative molecular mass. So we can actually get that. So we have mass conc of A over relative molecular mass of A. And this is equal to, the mass conc of A is given to be 7.30 GDMQ. The relative molecular mass is 36.5 gmol. So this is equals to 0.2 mole per DNQ. So I'll come back here. My Ca is 0.2 mole per DNQ. I've gotten that of A. The B says conc of B in mole per DNQ. So now, the only way we can get the concentration of the base, we can't use the formula mass conc over relative molecular mass because the X here is still unknown. So we use the CAVA. So let me put it here, B. Conc of B in mole per DNQ. We use the formula CAVA over CBVB is equal to Na over NB. We're looking for that of the base. So CB is equals to CAVANB over VBNA. And this is equals to the CA is 0.2 mole per dm cube times volume of the acid is 25 cm cube. The number of moles of the base, NB, is 1. All over volume of the base is 5 cm cube times number of moles of acid, Na, is 2. So cm cube, in short 25, we'll go with 25. So we have 0.2 divided by 2 will give us 0.1. So this is equals to 0.1 mole per dm cube of B. Yes. So CB is 0.1 mole per dm cube. What's next on the list? Molar mass of X2CO3. So we can now get our molar mass of the base. So let me print this. C. Molar mass of B is equals to mass comm of B over molar comm of B. The mass comm of the base is 10.6 GDN cube over the molar mass, over the molar comm, 0.1 mole per dm cube. And this is equals to 10.6 divided by 0.1 is 106. So this is 106 G mole. So that is the relative molecular mass in G mole of the base. 106 G mole of B. Again, they did not ask us to find what the value of X is, but perhaps if you want to do it, like I said, you may come across questions that will require that in future. So let's deal with that. So the relative molecular mass of B is equals to, now how do we get that? We say, okay, we have gotten that, sorry, not relative molecular mass, is the value of X, D, the value of X. So I have X2CO3 is equals to 106 G mole, which is the relative molecular mass. So this is 2X plus 12 plus 16 times 3 is equals to 106. Now 2X plus 12 plus 48 is equals to 106. Okay, let me cross over here. 40, 50, 60. 2X plus 60, yeah, is equals to 106. 2X is equals to 106 over, minus 60. 2X is equals to, now 106 minus 60 is equals to 46. 46. Now our X is 46 over 2. X is equals to 23 point something. Or 23. Yeah. Divided by 2 is 23. So now the value of X is 23. And if you were asked to find out, sodium have an atomic mass of 23. So this would have been disodium triazocarbonic. They did not ask us, but let's just keep moving. We've solved that already. Let's take our third question.